All right, good morning. Welcome back to Intro to Statistics. So we're going to be looking at 7.3 as sampling distributions. Chapter number 8, number 9. I think I've always picked these to put on a quiz. So if you're ever wondering like what could you do, you're gonna get like the typical ones like number 5, number 6 kind of an idea. But number 8, number 9, this has a little bit more to it. But this is the type of problem. I would put one of these on a quiz. I'd put the regular kind too. So it's important that you're able to do like a standard problem, kind of like a chapter 7.2 problem, and that you're able to do one of these. Okay, these are a little bit trickier, so I don't mind walking you through this. Like face-to-face classes again, I would walk you through this as well. So we have a roller coaster being designed to accommodate 60 riders. The maximum weight on the roller coaster can hold is 1,200 pounds. According to National Health Statistics reports, the weights of U.S. men is 189 pounds, and standard deviation is 63. They may give us the probability for women because there's going to be a part A and a part B here. Okay, for men, one for women. And we'll see what we can do with this. Okay. So the first one, and I'll pitch it pretty much the same way. Like I don't try to go out of my way. These are already hard enough. I pretty much leave them the same way that the problem has dealt them to us. Okay. So it says 60 people are riding the roller coaster. What is their total weight? And their total weight happens to be 1,200 pounds. What is their average weight? Okay, and this is an important part. There's always a nice thing to lead up to. So we're going to go to, okay, well, we have 12,000 pounds. And what did they want? They wanted that 60 people happen to be on this thing. So we're going to get an average of 200. So what we're going to do is we're going to take a slice of the population and say that our average or X bar, right, is 200 pounds. Okay, now it's not for the whole population. That is the sample of the 60 people that happen to be on here. Okay, so however many people get in line to ride on the roller coaster, that could be thousands, but we've got 60 people at a time. That is our sample. Okay, so we're going to go ahead and say that. I don't think we really need the calculator for that one, but we'll go ahead and say that that's going to be 200. Okay, so we have 200 pounds is our sample average. Okay, we got a green flag. So if a random sample of 60 adult men, so they're saying, okay, of the 60 people that are going to ride the roller coaster, okay, it's like fraternity day out or something. We're going to pick 60 men to put on this roller coaster. And then we're going to ask, what is the probability that the maximum safe weight will be exceeded? Okay. So what we're going to do is we're going to say, okay, well, we want the probability that this 60 people happens to be, what's the probability that this X bar happens to be greater than 200 people? What's our population look like? Okay, our population is drawn. I don't know what this is unknown distribution, but what was the average? The average of the distribution and the total. Okay, if I just pick out American men, right, that's 189 pounds. I should be so lucky. Okay. 189 pounds, and their standard deviation, okay, is 63 pounds. 63 divided by the square root of 60. Okay, now I don't know it's normal. All I know is that the average of this distribution is 89 and that the standard deviation is 63 divided by the sample size. Okay, can I say that X bar is going to be a normal distribution now? Is X bar, okay, is X bar, and what's the condition for it? The condition is either the underlying distribution is normal, we have no idea, or that our sample size is greater than 30. Well, we're putting 60 people on this contraption. That's bigger than 30. So we're going to say, hey, that's going to be a normal distribution. X bar is going to be normally distributed because we've got more than 60 riders. That means we can use our calculators to calculate some probability distributions here, calculate some probabilities. All right. So what we're going to do is we're going to get a norm CDF. Okay, we want our low rate because we want to know what's the probability it's going to be exceeded. Okay, so let's see. Safely hold an average. We want to be 200. Okay, and then we need a high number. Okay, so my scariest show on TV is My 600-Pound Life. So let's pick one of the bigger contestants on that was 800 pounds. Okay, because they're but for the race of God, right? That's always a fear for us. So okay, and then our average was 189 because that was the overall average weight of the population, and then a standard deviation was 63 divided by the square root of 60. Okay, and that's what we're going to be calculating here, right? So let's go with this. We're going to say, okay, I want norm CDF. Okay, so distribution. Actually, what is 63 over the square root of 64, or over the square root of 60? It's about 8. Okay, so if I've got to go 189 and count up by 8s, okay, it's at least 1, maybe 2-ish standard deviations away. Okay, to go from 189 to 200 by way of 8s. Okay, so it's going to be, I would guess about 5-ish% using the empirical rule. Okay, but we're going to double check with our calculators here and see. All right, so again, they want the upper part. You know, if the roller coaster is within safe weight, we don't have to worry about this. By the way, engineers apply a safety factor of like ×5 or something, so it's not, I'm not trying to scare you over roller coasters. We're elevators for the next problem. So we want 200, an average of 800 pounds. So if we had like all the contestants on my 600-pound life on the roller coaster at one time, that would probably not work out too well. Okay, and then we have an average of 189. All right, and then a standard deviation of 63 divided by the square root of sample size is 60. All right, so we're going to double check to make sure we're looking at the appropriate. It's a lot of numbers here. 63 standard deviation. Yeah, so I think we're okay. And we'll go ahead and put that there for probability. Okay, 0.08. That's a little bit bigger than 5%. Okay, but it's within the realm of possibility. So 0.0881. How many decimal places did they want? 1, 2, 3, 4. So we'll say 0.08881. Okay, so we have about 8% chance. Okay, I don't know if I would. I don't know if this one I would be a little concerned. Okay, that there's a probability that if there's a couple of guys like me on this one, that might exceed the safe weight there. Okay, let alone the contestants from like The Biggest Loser or something. That's not okay, but we'll check. Okay, hooray, we get our green light. So this one, 10%. For riding a roller coaster, I probably wouldn't accept that risk. But now we're going to say, okay, now it's a sorority day out. Okay, get all the women on the roller coaster. So they say 60 adult women. What is the probability that the maximum safe weight will be exceeded? Okay, so it's almost the same kind of a problem. Okay, it's just that we have a different distribution. Did they tell us that women's weights are normally distributed? No. They have 60 people on the roller coaster. There's 60 women on the roller coaster now, but we have an average of 165. Okay, but with a standard deviation of 76 divided by the square root of 60. Okay, so we're just going to go here and say, okay, we want norm CDF. Okay, 200, because that's still the safe weight. Doesn't matter men or women get on the roller coaster. Okay, the maximum average safe weight for this is going to be 200 pounds per person. Okay, and then again, pick a big number. Okay, again, that's my favorite. It's my big numbers for weights. Okay, and then we'll go through and we'll say, okay, what's our average? Our average in this case is 165. Okay. Kind of an interesting probability here because the average weights for women are lower, but the standard deviation is a little higher. Okay, so that's something to worry about. Okay, because it changes the problem a little bit, but this is 76 pounds. Okay, so this is 76 divided by the square root of 60, and we'll see what we get. Okay, I would actually assume that since this average is lower, this is still going to be a relatively small standard deviation because of the square root of 60 here. Okay, but we're pretty much going to type in the same idea here. So second function distribution, okay, norm CDF. Okay, we're typing in 200 as an average weight. That's the probability that we're going to exceed the safe weight. Okay, we'll type in 800. Okay, and then we have 165. And then our standard deviation here is going to be 76 divided by the square root, okay, of 60. All right, and we'll see how that turns out for us. So here we have, this is a much smaller standard deviation. So we ended up with 1.8043 times 10 to the negative fourth. So they probably didn't type that into the calculator very well. I'll try to do this with Alex, but I have a feeling that's not going to take that. Okay, because we don't have, right, we don't have an E over here. They just want 4 decimal places. So what we're going to have to do is convert this, and we'll say, okay, we have 1.8043 times 10 to the fourth. So we have 1, 2, 3, 4. Everywhere we have a blank, we're going to put a little 0 here. Okay, so we went 0.00018. Okay, so to 4 decimal places, 1, 2, 3. That 8's going to round this up to a 2. So we're going to say 0.002. Okay, so 3 zeros and a 2. We'll type that into 4 decimal places. Right? So 0.0002. Okay, so the important thing for this one is first off, make sure we have the right distribution. But the second thing, the second mistake I see most students make is they'll just type in 1.804 and they forget this e to the negative fourth here. Okay, it's important. It's telling you where the decimal place is. It's important to remember that. It's important to put that in. Okay, otherwise they're going to give us the wrong answer. Okay, so make sure you've put the right decimal place in. Okay, so we'll check, hooray, and then we'll see you in the next problem, okay? So this is very likely to be on a Chapter 7 quiz, okay? It won't be the only problem on there. I try to mix them around a little bit because I know these are a little bit harder in difficulty, okay? But chapter number 8, number 9, very good possibilities. Okay, I will see you in the next video. Thank you.